Yeah, we just see how to work with the same program in Kale. Let's say I have created a project with the name of 1, and I have created one file which is called interrupt.asm. See that you should have only one ASM file in this. You should not have more than one ASM file. Suppose if you have more than one ASM file, then you should have only one org00h. That and all you need to follow. Better you have only one ASM file in your source group. Let's say this is my program. You have seen as such in your manual, and how to compare, how to work with this file, how to simulate it, that just we see. I compiled it, assembled it, and there is no error and no warning. Go for debug session, click it. Now the things and all has changed. This is a memory, but we don't do any business with memory, but the people are often making mistakes with memory. What happened? The X stands for data memory, and the 0x4000 corresponding to 4000 hexadecimal address. Suppose if you want to see code memory, it's supposed to be C:0x what, any memory you can say. So this address corresponding to code memory. C stands for code memory and this X stands for data memory. This mistake you have done in earlier class. Now you correct it. Okay, coming to our program now. Let's say I'm going for debug. Yes, I have come to debug. The cursor comes here. Here you are using these three things. This is reset, and this is run, and this is to stop. Right now it is in stop, right? It is not running in any case. Before running it, you go to peripherals. Look at very carefully. Go to peripherals. Click this. You can find IO ports. Take port 1 because I need to look at the result which is in port 1.0. So I need to take port 1. Right? Port 1. Then again go to the peripherals and take port 3 where interrupt is associated with this port 3. Of course port 3.2 is INT 0 bar. Correct. So I am going to give here. What happened when I press here and when I release here? What happened, right? So when I press here, logic 0 is getting in, right? One more press, logic 1 is getting in. So that you need to look at very carefully. Right now just we run it and we see that. Reset it, just run. As soon as you run it, the stop button comes. If you want to stop it, you press stop it. Then if you want to run it, you run it. When you go out from debug session, you have to stop it and you have to go out, right? So now just run it. The program is running. Now what I'm going to do, I'm going to give an interrupt active 0. When I give first to 0, it becomes 0. The LED initially LED is on. That case and all we have studied in the theory class. All default value of the ports becomes 1. So LED is connected by default. When I give first interrupt, it switched off, right? So when I release a switch, it becomes again 1. When I give one more time, again it toggles. When I give one more 0, so every 0 giving in this, there is a change in this. Every 0, so INT 0 bar, right? Active low input signal. So whenever I have given the active low signal into this port interrupt 0, there is an effect on port 1.0 as per your program. So look at here, again one more 0, toggles. Give one more 0, toggles. Make it 1 and give one more 0, it toggles, right? So this is pretty good. Now you have to come out, just click it and come out. That's it, very simple, and you can do for experiment what the post lab question 2, where you are going to handle 2 interrupts. So when I press one interrupt, it should count up, port 1 should count up, and when I press INT1, it should count down. So you think of it and you do this as well. It is better to try for this also. So that is what the things you are going to do your experiment number 6. Thank you.